So here's another example of when regular reverse power rule doesn't work, U substitution doesn't work. And this doesn't look like a polynomial long division because there's a polynomial on the bottom, but the top is just a constant. So that doesn't really work out well. So let's remind ourselves of a couple things that are going to apply to this type of problem. The first thing is in Algebra 2 and pre-calculus, you talked about these things called perfect square trinomials. Here are two examples, x squared plus 6x plus 9 and x squared minus 4x plus 4. And what makes them perfect square trinomials is they can be written as a binomial squared. So trinomial means 3 terms, binomial means 2 terms. So x squared plus 6x plus 9 can be written as x plus 3 squared, and x squared minus 4x plus 4 can be written as x minus 2 squared. So this is what we're attempting to do in this problem so that we can get it to look like this form, which is the derivative of the inverse tangent function was 1 over 1 plus x squared, or du over 1 plus u squared. Remember, inverse tangent and arctan, they're just two ways of writing the same thing. It's pretty much the only hint you get at the beginning of your AP exam. So we are trying to use perfect square trinomials to be able to use this to take the antiderivative. So let's look at our first function. Again, sorry for the shaky cam. Hopefully I'll get better as these weeks go on. Okay, so the first thing we're going to do is we're going to look at this and go, that does not look like a perfect square trinomial. I can't just write x minus 7 squared, but that's what I want to write. So let's see how we can do that, okay? So we are going to take this number right here, and we're going to divide it by 2. So sorry about my thumb being like there. All right, negative 14 divided by 2. We get negative 7. And then we square that number. So we get positive 49. Okay? So what does that mean? Well, we can write on the top, we can write 1 over, and then we can write x squared minus 14x. And then we're going to add 49, but we're going to also subtract 49, so we didn't change the value, and then we write the plus 58. So you notice that this guy and this guy is this 49 right here, because we are trying to get it to be a perfect square trinomial that can be written as a binomial squared. So here we have x squared minus 14x. We're going to take the negative 14, divide it by 2, and square that number. So then we can write this as... We can write this right here as a perfect square trinomial. We can write that as x minus 7 squared. And then what's negative 49 plus 58? Well, that is going to be a positive 9. And then, oh my goodness, I've been forgetting my dx, people. My goodness gracious. There we go. All right, so step 1 is done. I have gotten my perfect square trinomial. What is step 2? Well, I'm going to pop up to the top of my paper. Notice how this is the u squared, or the binomial squared, but we need this to say 1, okay? So here's what we're going to do to make that happen. We're going to divide the whole bottom row by 9, which means you are pulling a 1/9 on the outside of your integral. Okay, so I am dividing the whole bottom row by 9. Oh. All right, step 1. Step 2. Do you notice that 9 is the same thing as 3 squared? I do. So I'm going to rewrite this as x minus 7 over 3 squared plus 1. Dx. Okay? So, why is that important? Because now, like we always try, we're back to u substitution, my friends. Do I have a u? Do I have an inside function? I certainly do. I have u equals x minus 7 over 3. And what do I do with my u? Oh, you remember. I take the derivative. Now, this is the same thing as dividing by 1/3. So the derivative is going to be 1/3 dx. And if you have a hard time seeing that, just know that this is the same thing as 1/3 x minus 7/3. So if I asked you, hey, take the derivative of this function, you would say it's 1/3. Okay, so this function and this function are the exact same thing. Okay, now most tutorial videos, they don't show you this step. I always like to show you this step so that we know what the dx is. And dividing by 1/3 is the same as multiplying by 3. Okay, so why do I like to do that step? Well, then when I come down here, I have 1/9 Okay, I have the antiderivative of 1 over u squared and the plus 1. And then do you remember what dx represented? It represented 3 du. I'm going to go ahead and put the du here, and I'm going to go ahead and put the 3 out in front. So I'm going to make this a 3. Okay, that 3 came from this 3 right here. Okay, so what is, oh, my goodness gracious, we're ready, because remember we were trying to get this to be the arctan function, and we got it. 3 over 9 is the same thing as 1/3. I'm going to write inverse tangent instead of arctan of u plus c. And then if you remember in our u substitution, the last step is to replace our u. So we get the following. Thank you very much for being so patient with these production values of me shaking the camera and my thumb always taking up the screen. Appreciate that. Again, we start off with a problem up here that looks like a problem. I can't use reverse power rule. It's not a special function. U substitution fails at first. Polynomial long division isn't looking too great. So I go, hey, I want to get a perfect square trinomial. I want it to look like that so I can make the inverse tangent. I've been taking the antiderivative of arctan. So step number 1, use a perfect square trinomial. Get it down to that. Step number 2, divide by that 9 so that I can get everything in here to give me a plus 1 at that end. Step number 3, recognize that 9 is the same as 3 squared, so get that inside the parentheses. Step number 4, use substitution. Step number 5, rewrite the integral. Step number 6, antiderivative. Step number 7, you have the answer. Congratulations.